Hello and welcome. In this video I'll be showing you how to expand brackets with Pascal's triangle. So let's get started. This right here is Pascal's triangle, and you basically just add the top two numbers to get the bottom number. For example, here you have 1 and 1, that equals 2. You have 2 and 1, that equals 3. It's a bit complicated, I guess, but you know, we use it to find the coefficients when we're trying to expand these brackets. So in this example right here, it would be a lot harder. Well, it would be pretty hard to like expand it using, I don't know, FOIL, where like you have x plus y, and then you have x plus y, and you have x plus y, you know, in all these double brackets, and then you expand it that way using FOIL. But we can use an easier way, and that would use Pascal's triangle and help us out. So I'll start off by writing, well, you could use x or y, but I'm going to start with x. I'm going to write x and then use the power in front of here, and then go down in descending order. So because it's positive, I'll be like x cubed, and then I'd be adding x squared, then I'd be adding a regular x, and then I'd be adding 0. So yeah, we're going from 3 to 2 to 1 to 0. And the next thing we're going to do is we're going to add in our coefficients. A coefficient is a number that goes in front of your value. So it's hard to explain, but I'll just show you actually. So if you have, for example, 5x squared, 5 would be the coefficient. So this would be the coefficient. This is what we call it. And Pascal's triangle gives us these coefficients. So if we look for this number here, so this number is 3, and we go to the corresponding row number, that's row 3, so that's this row right here. So I'm just going to underline the row. You can sort of see it, yeah. So 1, 3, 3, 1, that's row 3. So we're going to use these numbers, and we're going to just insert them here, and then yeah, that's going to be our number. That's going to be our not answer, but it's going to be part of our answer. So it would be 1x cubed, so 1x cubed, or you can just write x cubed, and then plus 3, because there's a 3 here, so 3x squared, and then we're adding another 3, so because there's another 3 here, so it would be 3x, and then add 1 times 0, that's just a 0, so we can just leave that as it is. So yeah, we're just going to leave it as 0, and then once we've done that, we can just add in the y, because now we need our y's, don't we? So we do it in the opposite order. So we'd start from y0, and then we'd go up to y3, and what that means is we're going to basically insert y, and we're going to do it so that, so if we do x cubed here, and then we're going to go y to the power of 0, and if you know what anything to the power of 0 is equal to 1, so you know this is 1 times x cubed is x cubed. But yeah, and we're going to keep going up. You don't have to write this y to the 0 here, it's just there so you can see the pattern that we're using. So 3x squared, and that would be timesing by y to the 1. I won't write to the 1 because you know that's just y, and then we're going to be adding 3x times y squared, because you know, going from y to the 0, y to the 1, y to the 2, do you see the pattern here? So y squared, and then we're going to be going finally to y to the power of 3, or y cubed. And if you notice, we're only going up to the cubed here, so we're only both in, like on the y we're going up to y cubed, on the x we're going up to x cubed. That's the maximum we get, so we can't go past the power that we've been given. So we've been given to the power of 3. Oh sorry, that's a bit wonky. We've been given the power of 3, so we can't go past, so wonky again, never mind. But yeah, you can see that 3, so we can't go past the power of 3 when we're expanding these. So now we're just going to be cleaning this all up. So y to the 0 is 1 times x cubed times 1 is the same, it's just x cubed. So we're just going to write that down here, so x cubed, and then we have to add 3x squared times y. That's what this means, so 3x squared times y. I'm just going to write that as 3x squared y, and then we have 3x, and we're timesing it by y squared, so we can just write that as 3x y squared, and then we finally have y cubed. So we can just write plus y cubed. And if you do it the opposite way around, so I've started with my x going from x cubed to x squared to x to 0, you could do this with y, it would be the same. I usually do it with the x because in most questions that you're given an x value, and in some questions you're given a number as well, so it wouldn't have to be y here, it could be a number. But yeah, I tend to go with the x, but it's fine to go with the y as well. And yeah, this is our answer right here. I'll just underline it. This is the entirety of the answer. But yeah, and obviously for this, it's only 3 right now, but it could get a lot higher, as you can see here. It goes all the way up to 5 in our little image here. It can go past 5, it can go into obviously Pascal's triangle goes to infinity, so this is only just 5 rows of that. But yeah, that means we can go up to the power of 5. You can obviously add more to the bottom and go up to the power of 6, to the power of 7. But yeah, if you're using powers that are greater than 2, or like especially greater than 3, maybe like to the power of 4, to the power of 5, these sorts of methods are quite useful to get your answer quite quickly, because using FOIL, well, like you write them all out. So if I were to do this same thing with x plus y, x plus y, x plus y, and just use FOIL, that would take a while, but doing this just is a lot quicker. It's a lot easier, in my opinion, if you know what to do. But yeah, we're going to go on to our next question. It's a lot harder than this one. We're going to be using a higher power. But yeah, hope this all made sense. And let's move on. So I'm in this harder question here. I've done a bit of working out already. I've already got my x to the 5, x to the 4, x to the 3, x to the power of 2. And then, got all this. Down here I've got my working out where I put where I just slot in the coefficients. So I've got 1, 5, 10, 10, 5, 1, because obviously it's row 5 and my power is to the power of 5. And now I've done all the working out that I've done from before, all the working out you'll know how to do already. And now I'm going to move on to the harder bit of this, which makes it a lot harder than everything else, and that is to do with this 2y right here. And yeah, I'm just going to start on that. So if we have x to the 5, we're going to have to slot in for 2y to the 0, and that 2y will go up as we go along this, so it'll go from 0 to 1, and then yeah, so plus 5x to the 4 to the power of 2y to the 1. And I'm writing 1 here because I want you guys to see the pattern that I'm making as we're going up. So 10x to the 3, 2y to the 2, and then 10x squared, 2y, and obviously we're timesing, so remember we're timesing this, so timesing like that. So yeah, and then 2y to the power of 3. We're going from 2 to 3 now, and then plus 5x 2y to the power of 4, and then finally plus 2y to the power of 5. Yeah, so now we're done, and we have to expand all of this now, and you've got to be very careful while expanding it because there's a 2 here, so you've got to actually multiply out that 2. And so what you do is you'd have in this first question, so you have 2 and then 2y to the power of 0, so this doesn't matter much because anything to the power of 0 is 1, so it will just be 1x to the 5, which is equal to x to the 5. So anything, so we can just leave this as it is. X to the 5, actually, you know what, I'll separate these, put little dividers between. Yeah, so it's easier to see. A bit wonky this, but yeah, little dividers, and yeah, so now we're gonna expand all this out. So x to the 5, as I have mentioned before, we'll do it in a different color actually. Let's go for blue again, x to the 5, and then this would be plusing obviously, so adding, and then 5x to the 4, 2y to the power of 1. So what does that actually mean? What we're doing here? What we're doing here is basically doing this 2, we're timesing it by the 5, so we'd get 10x to the 4, and then y to the power of 1. So yeah, that's we'll get that, and then we're going to do the same thing here. So 10 times 2 to the power of 2. You have to remember there's a power of 2 here now, so it'll be 2 times 2, so that'll be equal to 4, and 4 times 10, which will be equal to 40. So 40 x cubed, oh sorry, cubed y squared. And now in this next one, we'll be doing the same thing as before. So 2 cubed, 2 times 2 is 4, 4 times 2 is 8, 8 times 10 is 80, so 80 x squared y cubed. Finally, sorry, not finally, but yeah, in this one now we're going to be doing 2 to the 4, and that would equal, so 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 5, well, that would be 80 again. That'll be 80x y to the 4. And finally in this one it would just be 2y to the power of 5. Or you could just write that actually as, it would be 16, so 32 y to the power of 5. Now, so what we're going to do now is we're going to combine all this. So we've got our x to the 5, I'll do it in black now again, and this will be our final answer. So sorry this is taking so long, but it's quite a long answer, you got to make sure you don't slip up. But yeah, so we got x to the 5, you're adding 10x to the 4. Well, we're just copying it all down here. Hardest bit has been done already, so that was the hardest bit, not falling for this trap where you don't realize you've got 2y, not just a singular y, so you have to actually times everything out. So yeah, so now we've got 40 x cubed y squared, and then we've also got plus 80 x squared y cubed, and we've got plus 80 x y to the 4. Finally we've got, oh yeah, I haven't wrote that in, have I? My bad. Y to the 5. Right. Yeah, so now then we've got 32, so plus 32 y to the 5, the power of 5. That is your answer. And yeah, thank you for coming this far. And now we're going to be going on to our do-it-yourself questions, where I'm going to give you 2 questions and you're going to be doing them on your own. They'll be slightly different. They'll have numbers that are like actual integer numbers. And yeah, hope this has been helpful, and let's move on. So this question is for you to try. Just have a good go at it and pause the video here and unpause when you've done to get the answer. So here's the answer at the bottom here. So 16x to the 4 plus 64x cubed y plus 96x squared y squared plus 64x y cubed plus 16y to the power of 4. So that will be the expanded version of this 2x plus y to the power of 4. And you got to understand that you have to make sure to include the Pascal triangle values right here. And I think another thing to note is that you actually have to times this out. So if it's 2y, you have to times it out here, and also here as well, where like you've got 2x to the power of 4, you have to times it to the power of 4, which is 16, so it'll be 16x to the 4. But remember that, you know, it's not 2x to the power of, it won't stay like that, it will actually turn into 16x to the 4, and same for these. And yeah, well, I hope you got the right answer, and hope this question was informative, and hope you enjoyed. And that is the end of this video, and thanks for watching.